With work from home and remote scenarios being more common every day, we need a good way to secure those connections from outside of our networks. How do we do that? One of the best ways is through VPNs. What do we need to know about that for the Security Plus exam? Well, that's what we're going to start talking about right now.
You're watching IT Pro TV.
Welcome back to Security Plus here at IT Pro TV. Guess what? It's VPN day. That's what we're going to be talking about because it is a great technology and one that has been long used as a foundational secure mechanism for having remote connections for those people that love to go walkabout with their devices and still try to be productive. Wes, you're going to help us out with this because there's a lot to do when it comes to VPNs, things that we need to understand and know about, how we can set these up correctly so that we are not just bolting on something that is not actually doing what we want it to do, which is secure our networks. Where do we begin with VPNs?
Sure. Let's go ahead and start with the basics. Let's just describe what a VPN even is before we, kind of get into, well, what are our choices? Which VPN do we use? Are there more than one? Let's start with the basics. So VPNs, we love throwing acronyms at you, but what we don't like doing is not defining them. So that's a virtual private network. In the virtual private networks, when we've talked in other episodes about VLANs, right? So this is some kind of logical, when we say virtual, so some kind of logically made private network. All right, well, what's the point of that? Well, what we want to do is we want to secure communications over insecure networks. And we've talked a lot about that insecure network really being a public network and the internet for us. So here's our headquarters, right? You probably visited one of these places once in a while, right? Maybe a hotel, maybe a coffee shop, or maybe you got a branch office, right? Or remote office. And how do we allow our employees access, right, across these public networks with maintaining a level of confidentiality? Well, that's where the VPN comes in. It protects that privacy. And when I say privacy, I mean confidentiality of your data. And that's important to understand. We want to keep those unauthorized users that are connected to public networks out of our communications, right? We don't want somebody eavesdropping. We don't want an attacker, right, to get to our information, then maybe use that so that they can make their way into our corporate-based resources, right? So we want to stop that altogether. So that's really essentially what a VPN is. Just think of it as a way that we can create a secure connection, maintain that confidentiality and privacy, if you will, of the communications over a public network. That's really, in a nutshell, what a VPN is.
Awesome. So now we know what VPN is. We got some of the nuts and bolts surrounding that. Let's start talking about probably one of the most common ways in which we implement VPNs, and that's that remote access kind of idea. I kind of made a joke about it as we started the show, but this is really what we want it for in a lot of scenarios, right?
It really is. It's one of the more common ones, and it's got around the least complexity. Now, VPNs can be complex. Don't get me wrong, but when we talk about a remote access VPN, right, this is where, let's set the same scenario, right? We've got our headquarters, we've got a public network, we've got one of these locations, right? But notice that one thing that's changed, right? We don't have a remote branch, right? What we have is maybe a telecommuter, maybe somebody that's working from home, and we're here in the beginning of 2021. Many of you that are watching this right now, like Dan has mentioned, are working from home, right? So we want to make sure that we secure these communications, and a remote access VPN really is a type of VPN that allows a single client to make connections. So what do? We bring up this tunnel, right? And the tunnel is that logical aspect of it, right? That allows us to secure the communications across this public network. That really is a remote access VPN. Just think of it as a single user. Now, we can have multiple remote access VPNs, right? Many of you that are watching right now probably have a lot of employees, at your company that maybe they are connecting back into company resources, right? And the way they do that is with a VPN client, typically running on the host machine, some kind of software that allows you to enter the configuration parameters, or even easier, right? Admins like this, because we like to control this. We don't want our users to enter this information. We can create things like profiles that when the client comes online, it's basically checks, and I say online, when you bring up the VPN, it checks a configuration file and automatically configures the VPN according to the parameters that need to be set. and then we can tunnel that information over the public network. And we'll talk a little bit more about what tunneling means, but that's that logical aspect of it, allowing us to communicate across the public network.
Yeah, it's really cool stuff and does give us that flexibility and security that we need when we are working in those remote environments. Maybe we're at a hotel or at a conference, things of that nature allow us to give us in that flexibility to still be a part of our network, even though we're not inside of that actual network at that point in time. Now, another common way in which we use VPNs, especially when it comes to large enterprise solutions, is the idea of a site-to-site VPN. These are super helpful. And again, throwing on that idea of security, even though we're using public infrastructure. Wes, tell us more about site-to-site.
Okay, so one of the deviations between a remote access VPN is a site-to-site VPN. All right, you might also hear it called router-to-router, and you're going to see why they call that. And most commonly, it's called a site-to-site VPN. So let's go ahead and set up our same scenario, right? We've got our headquarters, we've got our public network, but what changes a little bit is now we've got multiple branch locations, multiple remote locations. All right, and what we do is these routers actually bring up the tunnels and connect router to router, if you will. So a little bit different on this one, right? Because now the routers are controlling the communication between the different sites, right? And we bring up the tunnel over the public infrastructure, and it allows us to communicate between branch office and headquarters, and vice versa. Maybe there's something inside of the branch office, right, that we need to communicate with as well. That is your site-to-site VPN. And also just kind of understand why it's called a router-to-router, right? This allows multiple employees in a single site to access the same VPN simultaneously. Now, there are constraints on it too, and that's typically your processing power, really, because you got to understand the tunneling by itself doesn't really protect your information, right? We don't just bring up a tunneling and use a tunnel protocol to create that logical connection, but that tunnel's brought up and then we encrypt the information. Now, keep in mind, information that's leaving the branch office, heading to the headquarters, or vice versa, is then encrypted, and it's the routers that actually have to do this. So one of the limitations to this can be is the fact that how many of those simultaneous connections can your router, participate in, right? They used to have, and they're still out there. I say used to have, but they're still out there. Like, for instance, Cisco has their VPN concentrators. If you ever hear that term, that's a term that literally has an aggregation board, a lot of processors, and what it can do is it can handle the encryption and decryption, so basically allowing you to scale up a little bit more. Now, the reason I say they used to have them, but they still have them, is because that functionality is really built in to those next-gen firewalls that we see today, where the firewall is doing doing many other things too, but one of the things that it can do is act like a VPN concentrator and allow you that encryption and decryption, because one of the things you have to consider when you're building this type of infrastructure is, how slow is it going to be, or how fast? Obviously, we don't want to set out for how slow it is, but again, you're usually limited by the processing power on the routers or the connectivity devices.
Yeah, I guess that would be a privation, right? The lack of speed, not so much. All right, yeah, we got to get it right. It's funny, when I worked in an enterprise solution, we had one user that had bought one of those cars that you put in your laptop, gives you cellular access. And this was before we had even 4G at the time, I think. And they were going through our VPN. They were accessing HTTPS resources, and they were like, "This is slow." I'm like, "Oh yeah, it is. Yeah. I am sure, no doubt." So we got that figured out for them. Try to speed things up. It was a bit of a nightmare, but we got it squared away, as you do. Now, another thing that I used to hear from my users quite often was, and this would be in our branch offices, was, "Hey, I'm on this connection, and you're blocking me from getting access to X, Y, or Z site. I pay for this internet access. How are you blocking me at the corporate headquarters?" Because the branch offices, they kind of paid for their own infrastructure in a little bit, and we would maintain it for them. How do I get access to stuff that I should have access to because I'm paying for it, and still be on our corporate network in some secure, reliable way? This starts bringing up the idea of making two tunnels. And this is the idea of split tunnel, right?
That's right. So what you're describing there, the latter, or the earlier part of that, is what we call a full tunnel. When you bring up that VPN tunnel, every access request, every resource request goes through that tunnel. So in this case, let's say we have a remote access client. Let me show you what I mean here. So for instance, in a split tunnel, we're going to set up the same scenario like we have our remote access clients, all right? Now, you can also do this with a site-to-site tunnel as well. I'm just giving you this example and the same example that Dan talked about here, right? Think about if you need to make a connection to something like, we bring up the tunnel, right? But you need to make a connection to whatever this site might be, notwork.tv. All right, don't go out there and look at notwork.tv. I'm just saying it doesn't really have anything to do with accessing the resources in the headquarters. All right. Now, it wouldn't make sense to allow the communication to go all the way through the tunnel to the gateway router, right? And then back out, if you will, to whatever that public resource is, right? So what we do is instead of allowing that, we create, like Dan said, a split tunnel, 2 tunnels. All right. And really, it's really
a tunnel and not a tunnel.
It's funny. They call it a split tunnel. And you're like, well, wait a second. Where are the 2 tunnels? Well, there's really just that one tunnel. All right. But now what you're doing is you are scrutinizing, if you will, the traffic. If it's a resource, I'm throwing out a resource here, right? It is a secure FTP server within the headquarters. Well, I want that information going over the tunnel. But if it's not work.tv, I want to just go ahead and go out there, right? We don't need to encrypt that information. We don't need to keep that information secure, right? Now, this, in the earlier days, a lot really was done to conserve your bandwidth, right? When bandwidth constraints were really, really, really tight. And not to say if you're having dedicated lease lines that they still aren't very expensive, but this is a way you could say you're accessing the resources within the network. Guess what? We want you to make sure that that goes over the tunnel, it's encrypted and secure. But if you're doing research, maybe you're at a vendor website. All right, or not a vendor website. Maybe you're at like a vendor's site in general. And you say, well, wait a second, I got to do a little research. I've done my research, but I also now, that based on that research, I need to connect back to the headquarters, right? Well, you're doing your research and you're not going through the tunnel. But the moment you need to connect to, if you will, the headquarters, that's when you're going to fire up that tunnel, and that tunnel is you're going to encrypt that information. Now, one thing that I didn't put in this slide is that concept of full tunnel. Full tunnel versus split tunnel. Full tunnel is the explanation that Dan gave. Everything's going through the tunnel, and we can say, nope, sorry, you can't connect to anything else. All right. Split tunnel, again, allows corporate resources to maintain their encryption and protection, and everything else goes out to the public network. The other thing I also want to mention, because it's not in the diagram, if we have a VPN site-to-site communication, we can do the same thing. We could say, okay, if you're going to go connect from the branch office back into the headquarters, well, we need you to go through the gateway or the site-to-site, the router, right? But when you're just doing normal communications, I don't want everything going all the way. Let's say if we've got a remote office in California and our headquarters is in Florida, I don't want it to have to go over slow WAN links, be encrypted, decrypted, and go all the way into the headquarters to come back out to the internet, right? So you can also implement a split tunnel and a site-to-site method as well. So just wanted to include that, even though it's not in the slide.
I'll tell you, Wes, when we implemented that site-to-site tunneling, that made a lot more happy people out there in our user land, and that was good for us to have to support them because less phone time with them, and that's always a good time. All right, now we've kind of got squared away on a lot of concepts when it comes to VPNs, right? How we can work with them site to site versus remote, all the other great stuff. But on top of that, or I should say underneath that hood, is some things that we need to worry about, things like protocols and encryptions that VPNs are typically using that we need to be aware of, A, so we can answer questions about them, that's always a good thing, and B, so that practically we can implement the right strategy for our environments. So Wes, could you speak to that for us?
Yeah, Dan, so we got to talk a little bit about what options do we have for tunneling protocols, and then also talk about encryption. Let's start with the tunneling protocols, because the interesting thing is it essentially creates the tunneled communications, but it's interesting because what it doesn't do is it doesn't really secure the communications, right? It allows more of the transport, if you will, of these communications. So that's why it's also got to be coupled with an encryption protocol. And I'll tell you that on the objectives themselves, they really only call out one protocol, and that's L2TP. But I want to show you some more options just so you're aware. I'd hate for you to get out in the real world and think, well, there's only L2TP, and that's not really the case. So got a little bit of a table here. Again, ladies and gentlemen, grab the flashcards. That's basically what this is going to be about. We have what's known as PPTP, L2TP, SSTP, and something known as IKE version 2. Let's start with the PPTP first. That is the point-to-point tunneling protocol. L2TP for the acronym, Layer 2 Tunneling Protocol, and then SSTP is the Secure Socket Tunneling Protocol, and then IKE version 2 is just Internet Key Exchange version 2. So let's talk about some of the pros between these, all right? PPTP, widely supported everywhere. It is an old tunneling protocol. Actually, it's really the oldest. Now, L2TP, Microsoft and Cisco got together, and what they did is they took the best functionality of PPTP and then Cisco's proprietary, something called L2F, Layer 2 Forwarding, and they kind of had a child together. No, just kidding. They basically took the both and they developed Layer 2 tunneling protocol. And there's a lot of support for it as well, and it has the really the strongest security. And I'll put a little caveat when we get to IKE over there, because the SSTP, one of the things that it allowed you, the pros to that, is that it allowed you firewall traversal. Because it's basically secure socket tunneling protocol. Think about secure socket when you connect to something HTTPS, right? That's going to be over port 443. So this allowed you the firewall traversal. IKE version 2, Internet Key Exchange version 2, one of its benefits is that it has mobility support. The Microsoft has their always-on type VPN communication and VPN triggering. So think about a mobile device that hops between wireless networks, right? IKE version 2 is really one that it supports that. In fact, you might even call it, or hear it called by its abbreviated name instead of Mobility IKE or Mobile IKE. They call it MobiKE. And that, if you hear that, it's the same term.
I thought it was a cyborg version of Dwight D. Eisenhower.
It very well could. Remember, the cyborg should never hurt humans. Now, let's talk about some of the cons to these. PPTP, it's been around for a long time, but it's a very weak encryption. We'll talk about what encryption is available for, but it's weak encryption. L2TP is really strong security, if you will. But again, with this kind of tunneling protocol, with the encryption behind it, you can start to see that performance degradation that we were talking about. It's very complex to set up. And the fact that it uses quite a few different ports means you could have some problems traversing that firewall. SSTP, its big issue, it's only available in Windows.
Who uses that?
Right? Yeah, exactly. So it didn't have a lot of support, and it's not widely adopted, and there could be proxy issues with it too. IKE version 2, it's limited support, and you also have to worry about it, and you'll see why with the encryption. There could be a potential for firewalls to block this type of communication. Now, let's talk about the encryption itself, right? I want you to be able to map the encryption protocols that you would have available if on the exam they said you have this type of tunnel. How do you secure it? All right, well, the encryption in PPTP was something called MPPE. That's Microsoft's point-to-point encryption. And again, it's very, very weak, so it doesn't allow a lot of security. L2TP is widely deployed with IPsec, and I'm going to go ahead and kind of skip over to IKE version 2 and let you know that it also is deployed with IPsec. So really, when I say L2TP has the strongest security, they really have the same security. They're both using IPsec, which allows you the AES, the Advanced Encryption Standard that we talked about in our cryptography section, as well as certificates. The SSTP, however, only went up to SSL 3.0. And if we know anything about
mistake.
Exactly, Dan knows that SSL 3.0 and anything below that too is pretty much being just phased out and has been phased out in favor of things like TLS, transport layer security, where you get that certificate-based and mutual authentication. So I want you to be aware of it. One of the final things I want to kind of throw out here that is not in the slide, because you got enough information, I want you to take the time. If you have to rewind it a couple times, please stop the video and rewind it. When we talk about PPTP, that is port 1723. L2TP uses port 701. Anything that's using IPsec is going to use UDP port 500 and UDP port 4500 as well. And that's important to keep in mind why I say there's a potential for firewalls to block it, right? You got to have the UDP ports. Think about it. UDP in general is kind of this connectionless based protocol. So yeah, do keep that in mind. So remember those ports as well, because we've talked about those. It is important to understand ports so that you are aware in case they put you in a situation where you have to identify what type of VPN communication is set up, and all they're giving you is ports. So as a security professional, you should be aware of them.
Well, there is VPNs wrapped up and a ball for you good folks out there. Remember, we took a look at the different ports and protocols that Wes was just rattling off for us. Stuff that's just going to be brute memorization that we need, but also the concepts of things around like site to site and remote access VPNs. And don't forget the idea of using that wonderful split tunneling that everybody just is raving about these days. So be on the lookout for that. That being said, we are out of time for this episode. We got more to come in the Security Plus, so never fear. We will be back for more. Hopefully, we will see you then. Until then, have a great day.
Thank you for watching IT Pro TV.